Check, check, check. 1, 2, 2, 2. Check, check.
come first and decide. It's hard to explain it. Every heart's way a step. And the water's getting deep. Do we swim or do we sink? 'Cause there's still a long, long way to go. We're in over our heads. We're holding our breath. Will we ever get to the other side before there's nothing left? Yeah, our bodies are weak. We're tired of hurting. Will we ever get to the other side? Don't know, but I swear I'll die trying. Can't say yes, can't say no. This thing's out of my control. It's hard to explain it. Heavy hearts weigh us down. Water's getting deep. Do we swim or do we sink? 'Cause there's still a long, long way to go. We're in over our heads. We're holding our breath. Will we ever get to the other side before there's nothing left? Yeah, our bodies are weak. We're tired of hurting. Will we ever get to the other side? Don't know, but I swear I'll die trying. Shake my wrist down to a sinking ship. I got tried. Oh, I got tried. We're in over our head, but we're holding our breath. Will we ever get to the other side before there's nothing left? Yeah, our bodies are weak. We're tired of hurting. Will we ever get to the other side? Don't know. I was a hot mess in my Sunday best, black tears in my eyes. You were my first love, you were my only one. I can't believe your lies. Once we were like battle rockets, now I know I have to stop it. Please believe me, this isn't easy. I just need to say goodbye. Goodbye, goodbye. Losing my mind. Goodbye. You got a new friend, you like to play pretend. I'm just keeping my cool. Turn on that smoke machine, magic and make believe. She'll never know you like I do. Once we were a fire burning, now you're just a lesson I'm learning. Please believe me, this isn't easy. I just need to say goodbye. you should talk. I think you should leave. You've got a face that makes me feel gone. I've got a place where we can lay low. I prefer better, though I prefer you. I used to be sweeter, but I prefer you. I prefer better, though I prefer you. I prefer you. We've gotta be meaner if we mean it this time. With a ruthless mouth and a vicious mind. Maybe I'm bored or maybe it's you. It might be good if we could be two. I prefer better, though I prefer you. I used to be sweeter, but I prefer you. I prefer better, though I prefer you. I prefer you. I prefer better, though I prefer you. I used to be sweeter, but I prefer you. I prefer better, though I prefer you. I prefer you.
All right, we're going to start in just a few minutes, so if you could find your seats so we can get started, that would be great.
I'm trying to keep my feet up off the pavement. Everything I thought I knew keeps changing. So close that I can taste it. Seeing ghosts of friendships I've been craving. Standing in a line that I created. So close, I should take it. We looked away, then looked right by. Know the future got here so fast, so fast. It's a lovesick feeling when you just want it all. It's a knowing that the hardest part is letting go. Trying to make the best of every moment. Reaching out for something I can't hold yet. So close, arms open.
All right, please find your seats so we can get started. We're going to get started in about 30 seconds. All right. Hi, everyone. Welcome to the third GraphQL meetup here at MDG. My name is Jonas Helfer. I'm open source developer here at Meteor Development Group, and I work mainly on Apollo Client, but also on our other GraphQL-related projects. So first, kind of a show of hand. Who's already using GraphQL or has tried it out here? Well, that's quite a couple people, I'd say. Roughly half. For who is this the first GraphQL meetup? More than half, I'd say. Oh, that's really awesome. Yeah, so we're really excited to kick off 2017 with another GraphQL meetup here after hosting GraphQL Summit, also in San Francisco here in October. So as I said, this is the third GraphQL meetup we're organizing. The first one was sort of about the community and about the momentum that GraphQL was really developing. The second one we had was about using GraphQL in production, where we heard from some larger companies like Credit Karma or GitHub, who are using GraphQL in production already. And today we kind of want to do a deeper dive into sort of GraphQL in practice and hear from some seasoned veterans or hear kind of some stories from the battlefield about, the lessons learned from using GraphQL and kind of trying to pass on some of that knowledge. So first up, we have the CTO and co-founder of Verbling, Gustav Reidstedt, who's going to be talking about tips and tricks for designing schemas that he and his team have learned since they started using GraphQL. So please welcome Gustav.
What do I do with this one?
You just throw it away.
Throw it away. Fuck it.
You need sound?
No sound. I think. Oh. What's up, guys? How you guys doing? How are the sandwiches? You good? Cool. All right. Everybody see it? It's good? All right, cool. My name is Gustav. I'm the CTO and co-founder of a company called Verbling. I didn't see when he did the whole reach of hands. I kind of want to get a better idea because we're going to talk about some tips and tricks, and I kind of want to get a feel for where people are. So who's like never done anything GraphQL? This is like, you're just here to check, oh cool. Who's kind of been tipping their toes in a little bit, checking it out? And who's like full-blown GraphQL in production? Wow, so there's like a cool mix of people. So I guess I'll keep it somewhere in the middle, and you guys like stop me when you want to hear more, or tell me I'm stupid if I'm being stupid. So Verbling is a language learning platform. We connect language teachers with learners, and it's a video platform, and we build tools and payments around that just to facilitate that sort of transaction. Been around for about 4 years. It's still a very small team, but we're growing fast, we started using GraphQL right actually when Facebook first released the first version of Relay. Didn't go full-blown sort of production, but we started tipping our toes a little bit, trying it out on some features. Today, about a year and a half later, we're pretty close to 100% migrated away from REST as a main sort of interface. We're about 200 GraphQL types, you want, which is not huge, but it's not small either. About 250 mutations on those types. And we started off, as I said, we started off at REST like everybody else. And we had this you start a company, you have this grand idea, and it was like, oh, we're gonna go for REST. That was the cool thing back then. And you start planning out your interface, and everything seems perfect, everything seems great, and you code it up, and you go to bed feeling really good. And then you wake up, and you have like 10 times more features, you have 10 times more users, and you start getting these requests from like front-end engineers, right? You're saying like, hey, I like this thing you built, like this cool interface, but I really don't want to make like multiple round trips here to get the same data. Can we start like compacting them in and making one custom endpoint, or maybe multiple, or let's just all have custom endpoints all over the place? I feel like you guys know where this lands, right? Like you start with a perfect idea, and you end up somewhere where you have all these aggregated endpoints. You want, you want this little piece of a user, but you also maybe want their, for us, it could be like you want to take the lessons they've taken, and this becomes really messy, especially in the back end when you try to be really good about caching. You try to be, it gets really messy. So, at least in my head, when I started seeing the cracks of REST, you start thinking about it. What if I could you have this language that I could give to the front engineers, right? That they can oh, I want these things, give me these things and package them up in a cool way and send them back, right? I feel like we all had those ideas, but nobody had the time and the money or the resources to implement something like that. It was sort of a vision. Facebook has a lot of money, and they're a lot smarter than I am, so they came up with this really cool idea. So we jumped on board right away, and really lucky we did. We're loving it. We don't want to go back, but I want to talk about some of the learnings and some of the things that we learned along the way. So let's make a list. The way I was thinking about doing this, let's first talk sort of grand designs, sort of just bigger picture stuff, and then we go on some really granular stuff. If you guys want to hear more about the big picture stuff or less, you shout out, tell me something. Let's start at the very top. So the way that I think that you go from a REST house, if some of you guys who are still sort of dabbling and try to get convinced to go there, the way that I think you need to go is really to get into a graph sort of mindset. And this might not seem so obvious, but I think that's the first thing that you have to do. You have to start thinking in graphs and not in endpoints. REST is very much about defining an endpoint to do a certain thing. Sort of try to scrap that from your head and instead think about how to model your data in graphs. Think about all the both direct database models and abstract models that exist within your application and start thinking about them as a graph. Really, I think the most basic thing to do is get a big sheet of paper and you just start mapping out. It's like, okay, I'm going to start off, take whatever database you have. You just start mapping out all the tables or the models that you have. And then you start doing all the edges between them. How do these connect, right? Once you do this, then take all the abstract things that could happen around them. And we'll talk a little bit more about that. But that I always say, you start by mapping that whole space out, and then stop thinking about designing endpoints into this graph. You're saying, all my front-end engineers now have this graph. How do I empower the display of the data of this graph? Don't think about how do they get into the graph, how do they query a graph. You just assume that they can query the graph in some way. I mean, there are lots of ways to do it in GraphQL, but that is the mindset. And I think that probably is the biggest thing if you take away from this. Try to force yourself into a graph mindset. Hard to explain, but graphs, man. Another thing I would say is approach carefully. GraphQL and the sort of the environment around it is like a crazy Swiss Army knife with all the shit that you want. So I would say approach it with care and really plan out how you're gonna build out your schema. Because I feel like in a lot of ways you can go wrong in many ways. You can build out schemas that are not gonna be performant, they're gonna just represent bad data, they're not gonna scale, so I would say really take care before you really jump into GraphQL to plan out your schema. So start out with a small test. If you're jumping on board, start taking one thing, map out that one thing. It could be like a user profile. Start thinking about what are these components? How do I represent this in my GraphQL schema, right? Start there. Don't try to do a full-fledged thing or the entire application. Start small. And invest time in really thinking about, we'll talk more about naming, but really think about how this is going to be used now and how it's going to be used for a long time ahead. I think also it's important to still realize that, this came out of Facebook. Facebook has a lot of resources, and they have a lot of tools built around GraphQL that we necessarily, as a community, don't really have access to. There's a lot of great stuff coming out of places like this. But if your application or your company has specific domains where there isn't really a set in stone way to do authentication in GraphQL. Security isn't completely mapped out. Like DDoSing, for example, or monitoring. These are things that are not they haven't been around for 15, 20 years. We don't really yet know what the best practice is here. So if those are things that are super important to your company, you should think carefully about it. When you map out, I touched a little bit on this, but when you map out your schema, don't only take your databases, several databases, and map them out. Also think about abstract components of the application. And I think this is really where GraphQL becomes really powerful. One thing we do is we actually map some third-party APIs that we use to call on the front end, and we just wrap them in a GraphQL schema. That's a little cool thing. But there are more abstract models in your application that are not necessarily core data models that could be really nice and useful. I think Lee Byron, he brought up, for example, search is a really important thing in GraphQL conference. You can create really powerful models where they are sort of backed, search, for example. You search, and the search result might be your data models, but you can wrap that in a lot of metadata, suggested search, or closer search. So you can really dig deep down and represent more abstract relationship between models. We have a cool thing, for example, we have in our backend, we have a model for a student, we have a model for a teacher, right? We don't have a direct model for a relationship between a student and a teacher. But that's something that you can easily define in GraphQL. So start also thinking about what are the relationships between the edges of these different database models. So yeah, a takeaway, I guess, is don't just stamp your database and that's your GraphQL. Think more. More actually asset metadata and search results are some ideas. One really important thing, and this was also brought up at the GraphQL conference, which is great, design for the future. GraphQL is a versionless API, so you really want to think hard about it. Naming is hard, we know that. It's even more true in GraphQL, I feel like, because of the versionless of it. Can a new engineer that comes on board, can he just open up graphical or something? Can he understand the entire schema? Are you leaking implementation details, for example? Is the naming and your schema, is it supporting version 2, version 3 of your feature or your app? Does it also support new environments, regions, devices, right? Think about these things carefully, because if you don't, you're just going to end up extending the schema into eternity, right? And we don't want that. Another thing that I think is important, don't forget about your fundamentals that you learn in computer science school or whatever you went. Modularize your graphs. We don't want to end up with these enormous objects that contain all the data you want for application, right? Modularize. Think about like how do these different aspects of my application, how do they tie in together, and how can I be smart? How can I be a good computer scientist or a good coder, and how do I modularize this? Don't forget about your core like sort of object-oriented concepts when you're designing your schemas. Still think about it. Single responsibility principle, like one model should probably represent one thing. If it's representing 5 things, you should probably rethink it. High implementation details, pretty obvious, but can be, it happens to the best of us. Don't carry states to the graph. This is sort of I guess a lower level thing, but as you're querying the graph, you don't want to be carrying data through your edges to rely on the resolvers. I don't know if that makes sense. So if I start here at some node and I pick up data on the way of my path, I don't want to rely on the fact that I enter the graph at this place to query to resolve the data model over here. Each model should be resolvable, hopefully by itself, with little to no other data. Does that make sense? Okay. That was a little abstract, but I have seen it, and it does happen if you don't think about it. Self-document, I mean, one of the most powerful things of OpenGraph, I think, is the self-documentation. But it doesn't really happen by itself. You have to be diligent about it as a team. Always fill out field and object descriptions. Seems pretty obvious, but I actually ended up writing a test that makes sure it's like if you're committing something, you better have a description on the field or the object. These things are important things to start off early, so you get the sort of the super powerful self-documentation aspect of OpenGraph. Use the power of enums. Don't use floating strings that are they could be an arbitrary thing. If you're bringing on a new engineer and he sees this cool cool objects, like what can this field be? Like show me the values. So don't forget the power of enum. It's easy to just slap a string in there and be cool with it, but use enums. Naming again. Like think hard about it. People are gonna read this maybe when you're gone, 10 years from now if the product's still around. So think hard about it. Okay, so that was kind of my high-level stuff. Now I'm gonna just go on some really detailed stuff that we've found some use in. Polymorphism. There might be some controversy here. OpenGraphQL, my opinion is, don't do it. If you disagree, we can go have a fight outside or something, but there's some support. There are unions, there's some basic support for some polymorphism. My honest opinion is you don't. It's the same way that some polymorphism probably isn't very well suited for your actual database backend. Don't do that in GraphQL. Your resolvers are going to be much harder to do if an object is represented by potentially an n number of other resolvers. You're gonna have a harder time caching that resolver. It's gonna be harder to argue where the data came from. It's gonna be harder to test. Here's a simple thing that we do. A user can also be a teacher, can also be an admin. We just represent them as direct objects. And they might be represented as the same sort of same object in the back end, but it's just much easier to argue about the data this way. But I would love to hear if you guys don't agree, just tell me, fuck off. While you're designing your schemas, use the opportunity to dry up your client-side code. So here's some examples. So here's some long thing where I'm checking if this user that is queried is actually the same user that I'm logged in as. This is a common thing. I'm looking at my own profile. For example, this code can show up everywhere. Just take the opportunity to extend your user schema with some contextual information based on who I'm authenticated as. I can just do user.isme. It's not always like, sometimes you stamp your user model and you're like, oh, that was it. Well, think about some of the cooler things that you can actually help out your front-end engineers do. Here's another thing, is admin. Instead of doing some like pulling down all the roles to the front end and doing an include or something, you can just do a simple thing like this, has role. Authenticated querying. This might make sense for some of you guys have done GraphQL for a long time, but it might not be obvious that when you're visiting a node as an authenticated user, you can do some really cool things. So here I'm visiting a teacher fragment from an authenticated user, and I can actually get my lessons. That's a pretty cool thing. I'm moving into the graph with an authenticated context, and it really empowers. You can do really, really cool things. So don't forget about that you have that information. I have the information. I am logged in as this person. What is my relation to this data or this object that I just looked at? There's more. My progress we have on the lesson. I'm following instead of like querying some long thing of like followers or something. I can just ask, am I following this teacher with me as logged in? It's really powerful. So start thinking about that too. It's like, okay, I'm looking at this model. What can I gather from it that I don't have to like offload on the client? Okay, here's another pretty powerful concept that when you are coming into an object or a node in your graph, it's sometimes pretty useful. At least like makes your code pretty clear if you know who your parent is. So here's who the edge that you got there into. So here's a pretty straightforward example. I'm getting into this lesson connection. So I want to see this is just some lesson query. And if I'm coming from a teacher, I actually want to see the lessons from someone who taught lessons. And if I'm coming from a user, I want to know the lessons that user took. Does that make sense? It's easy to forget this, and your code is going to just become a lot simpler if you're able to argue about the edge that you came there with. So don't forget that you have that information as you're querying it. This is sort of the last thing. There's a lot of discussion and sort of ideas on how to authenticate best in GraphQL. I don't know if the community as a whole has landed on what is best. You could like hide the entire schema behind another endpoint or something. You could split up objects so that like certain models are authenticated. What we've done that we think is pretty useful is being able to, on a field-by-field basis, argue if the authenticated user should have access or not. Here's an example. We created this simple middleware that there's a gist for it, where I can say if I am an admin or if I am myself, allow the resolver to continue on email. We found field-by-field authentication to be a lot simpler than any alternatives. Also interested to hear what you guys think, but it's a lot easier than having to block entire edge traversals, for example. If you cut it off, because it just gets really hard. You have to deal with a lot of nulls and a lot of throwing of errors, and so we don't do that. We just say you're not, as this person, allowed to enter this field. So yeah, that's pretty much it. Verbling is always looking for people. We're growing really fast. We're doing exciting GraphQL stuff. So yeah, open up for some questions or throw a tomato or something.
Thanks, Gustav.
Yeah.
Do you have any questions? Over there.
So going through kind of your lessons learned, did you give much thought to kind of the performance perspective of, okay, you want to create these more simple types and have more type explosion versus generic types? Mm-hmm. How does that have a perfect impact for going and loading all this data?
So the question is, more complex object versus simple, or use more objects?
Right, and so when building a graph of data,
Mm-hmm.
if you're not getting all this data at one time, you could easily get into like a n² scenario where you've got to keep going back to the source of truth and getting more and more data.
Yeah, so we use a data loader from Facebook and also some other caching. So, there's certainly, you can certainly make circular sort of traversals that will have some performance impact. I'm pretty sure you can DDoS our site right now if you go, we go try. It's something that we're working on, but our caching layer is working pretty well. So if you're, if your graph if your traversal ends up ever querying the same ID of the same object, that resolver is ever done once per sort of call.
Have you got it to the point where you can do just a batch request to get everything at one time, or are you still?
Per project, per ID, we do one, but we don't batch up. No, we don't do that.
More questions?
Hi. Thanks for the presentation, by the way. So if you do field-by-field authentication, how do you handle, like, if you're not authenticated, do you return null?
Yeah.
So your front end, you have to check for every field if it's authenticated or not. So you have to check all the nullability, right?
Yeah, I mean, this is an early, I remember having some discussions with the Facebook guys, and I think this was kind of a design pattern that the GraphQL community kind of was forced into because of decisions made by Facebook. And that's like, you should be able to deal with nulls. Like, you should be able to deal with most of your fields being null at some point. So that's kind of, I guess we've kind of embraced it. Like, we're kind of okay with dealing with nulls because there's a lot of other things around GraphQL that like kind of demands you to deal with them. So yeah.
All right, thank you.
Yeah.
Hey, a little bit more high-level question. Initially, you started out by saying REST is convoluted in a sense, especially as you develop it over longer term. But then you went into a rant about planning for the future. Sorry, the rant word, but think about the model, domain-driven design, object-oriented encapsulation, and so on and so on. And I think this is great, but here's the question. Would you still consider using REST for certain parts of the application stack where it makes sense? Because I always believe, single technology is never the solution. You should apply a tool where it's needed best.
Right. Yeah, sure. I mean, I think where the power of GraphQL comes in consideration with the client. I mean, it's a query language for the client. So certainly REST for backend services or, for other, yeah, certainly. Yeah, it's not a, but I'd say we wouldn't go back to REST for any sort of client-side code, probably.
All right, we have time for one more question.
Hey, so you said you used a relay from early on.
Yeah.
How has that been?
It's been good. Mutations,
Yeah.
I hear a lot of complaints, and I agree. The interface is not completely straightforward. I've heard rumbles about it changing, about their new things coming out. I'm looking forward to that. Other than the writes, it's been pretty good. I mean, it was rocky in the beginning. It was immature when we first landed it, But yeah, my biggest gripe is probably mutations. And then I was hoping that sort of an idea behind subscriptions would have gone faster. I mean, there doesn't seem to be super clear consensus, at least outside of Facebook, how to do it. We've been trying to, we're experimenting with it. But yeah, other than that, it's been good.
All right, let's give Gustav another round of applause. All right, before I introduce our next speaker, some quick logistics that I didn't say at the beginning. So we're going to have 3 speakers tonight. That means 2 more. We're going to have a quick 5-minute break at around 8 o'clock, and then the last talk should be finished at around 8:40. All right, so our next speaker is Chris Biscardi. Chris is a senior engineer at Dropbox, where he builds core UI tools. And he previously also built the UI team at Docker. Here he is. Yeah, I haven't seen him before. So yeah, please give a warm round of applause for welcome for Chris.
Test that. There we go. Cool. Nice 1080p. Cool. So I'm Chris. Like I said before, I work at Dropbox right now as a senior engineer. Before that, I built the UI team at Docker, and before that, I did a lot of consulting for many years. If we're going to talk about sort of content-based sites and sort of how to generate GraphQL APIs for them, we have to sort of define what a content-based site is. And it's pretty simple. It's sites that draw on content that come from various areas. It sounds vague, but some examples of these are markdown files. Systems like Jekyll, Middleman, Hugo, all generally use or support markdown files with some sort of front matter. Maybe it's YAML, maybe it's something else. And these sort of take markdown in and spit HTML out. You can get more data from content management systems like WordPress or Contentful. Many of these have REST APIs. Some of them don't. And some of them, like WordPress, have recently grown REST APIs, depending on how you feel about that. And then for Git repos and open source projects, you have documentation that's versioned across multiple branches, multiple tags, multiple releases. And you want to sort of pull all of that in and then generate sites based on that content. And then finally, you've got JSON files or third-party APIs. They're basically the same thing. Maybe you want to fetch your top repos from GitHub for your personal site. Maybe you want to get the tweets from Twitter for a client site. Or maybe you want some YouTube videos from, YouTube. Content-based sites are distributed in multiple forms. Static sites, such as the generator Hugo or Jekyll, are quite a common occurrence. And then you get into sort of more progressive web app style content-based systems. And these are built using app shells and manifests and service workers and things like that. There's a project that I've built myself called Leo, which uses the GraphQL style APIs that I'm going to talk about today. And there's also another project called Gatsby that many of you may be aware of. And then finally, you can distribute a sort of a content-based site as a universally rendered application. And the difference between a universally rendered application and a system like Leo or Gatsby isn't that different. For example, Docker Hub is a universal application that renders static HTML and then bootstraps a single-page application on the back end, or on the front end, but after it loads. And each of these needs a data pipeline. Some of these are a little more ad hoc-y, sort of like Jekyll or something like that. But basically, they all need to take Markdown or some content type, JSON from APIs, and they need to turn it into HTML that the browser can see, sort of JSON and script bundles, manifest and server worker scripts. And I would argue that the correct way to do this these days is to use GraphQL as that interface. So we have a problem. We have a lot of different content types, and we have a lot of different sources of data that we can get it from. One example is a blog post, like I mentioned before, where you can have Markdown with front matter, and that can come from a Markdown file, or it can come from WordPress or Contentful as an API call. But the blog post itself is a representation of that data. It isn't the data format itself. So we would like to use GraphQL to specify what we want that blog post to be. And then there's other situations where you get blob content. Maybe you're using an early version of a WordPress API, and basically you're just getting HTML blobs shipped down to you, and you have to do something with them. And then there's other more complicated content types, like case study for an artist, or maybe your client work has varied applications and you want to display it all so you can get more client work. And these things will have images and media and sounds and things like that. So generating these schemas is about combining these data sources. So for example, let's say we have a blog. A lot of people raise their hands and that they're familiar with GraphQL. This is the GraphQL shorthand for those of you who have not experienced it before. It's basically saying we have a query type. There's a couple of sort of keys here that we can query on. A post is identified by a slug, and it returns you a blog post, et cetera, et cetera. So that's our goal. That's what we're trying to create from these disparate sources. So for that, the purposes of the schema, it doesn't really matter where these are coming from. When we're building our site for our client or for our company, we don't care that it's coming from GitHub. We don't care that it's coming from Contentful. We just want the data, which makes GraphQL a really nice solution to the problem. So for the simple case, you have pre-prepared content types, like Markdown with front matter, right? You've got this blog post, and sort of any computed properties will get stuck on this attributes key of this blog post. And then we have some standardized keys here, one being the raw body, which is a raw Markdown file, right? Just the output, in case you want to render it on the client side, right? And the other is the body, which is the actual rendered Markdown file, and will come out as HTML. And then there's the other things that you want to do to this blog post as it's being processed so that you can expose on when you're querying, right? These things have titles, these things have slugs, published at, the URL that you want to render it at, and then maybe more exotic things like the excerpt, like maybe the first 10 seconds worth of reading of this blog post so that you can include it in a list of 50 other blog posts. And then things like Medium have popularized, like time to read, right? You want to do a calculation based on the average words per minute of your average reader. So what you can get out of this is basically if you construct a plugin system, you can create plugin schema fragments using basic objects. In this case, you can see that this post fragment correlates very well to the schema that we saw before, where you have a post, you query it with a slug. The slug is the unique identifier in this case, and it returns you a blog post type. And you have the same thing with posts for this blog post plugin, right? So if we can create these plugin fragments, it becomes really important to figure out how to combine those into a GraphQL schema that you can then introspect and query with, say, Graphical or Apollo or Relay or something like that. And there are a couple options here. The most common one is object.assign, funnily enough. So basically, you just take them and you put them all into the same object. There are obvious disadvantages of that. So there are other tools out, such as GraphQL merge or GQL merge, These are two different packages on NPM right now. They are both very, very, very low versioned, so like 0.0.1 and 0.0.4 kind of thing. But they basically exist to do is merge two similarly named schema types into one. And then you have to deal with a more complicated resolution function, but you can actually get this schema to merge. And then there's a further one, which, because we're building content-based sites and we're doing this all basically at build time, we can use introspection queries and then merge the introspection query results for clients like GraphQL so that we can then pretend to have one GraphQL API, whereas some queries are actually getting sent to the GitHub GraphQL API and some queries are hitting your disk. So again, the object.assign is fairly simple. You basically have some system that maps over all of the plugins that you have and applies them all to the same object. You get this query fields object and you stick it on your root type. And this works really well. It has a couple problems, a couple of really obvious problems actually. You get name collisions if you have multiple types that are the same names or the same similarly named types that are different things. You'll get collisions when you go to actually use these. And the other problem is that the types aren't really extensible, right? If you have a blog post that doesn't have an excerpt or doesn't have time to read, and you want to add those things into that blog post, you have to create a new fragment and then merge that new fragment in, which is kind of a pain if you want to have reusable content types across projects. GraphQL merge and GQL merge are a little more sophisticated in what they do. And you can basically specify in shorthand these query schemas. So in this case, we have a top users query, and it has a first name, a last name, and then we have this other plugin that's like, hey, by the way, top users also have companies. So what these packages will do is actually merge those types when it sees that they're the same type, and you get a top users query with all three of your fields. So we've solved one problem, and we've sort of introduced a second problem. We still have name collisions. The types are now very extensible, but with the extra extensibility comes an extra big problem with the resolve functions. So now you're merging these types together, but you also have to be merging these resolve functions together in some way. And the other one that I'll mention is that GraphQL tools also includes some functions to merge types together in a similar way to object.assign. I'll just leave this up here for a brief second in case you've never seen the Apollo tools being used. Basically make executable schema, takes a bunch of type defs, a bunch of resolvers, and gives you something that you can execute your GraphQL queries against. And then maybe you want to generate some of these schemas sort of on the fly, right? We don't want to always have to pre-write all of these blog posts and media types and things like that. So if we generate them, we get more reuse, because that means we can use any other content management system like Contentful, and we can import and export our content types out of Contentful. And then we can introspect whatever's in Contentful, write out our schema.json file, and do query analysis based on that to know if we set up our CMS correctly. And then obviously the encapsulation of being able to do that. And the question sort of stands like, what are we going to generate these things from? And like sites like Contentful have REST APIs where you can get introspection information about the content types that you have sitting in Contentful or your CMS. And then there's other things which are a little more advanced, such as the GitHub GraphQL API, which obviously has very rich introspection capability because GraphQL. And Contentful content types are just sort of like You go in, you click a few buttons, you have a couple fields, maybe you have images. It's all either GUI or API based, which is really nice, because if you don't like it, then you can write your own front end. And we can introspect this contentful content type endpoint, and we end up with something that comes back and can be very directly translated into a GraphQL schema. Right, so in this case, I've cut down the response, and the fields that you get back are title, body, category. And title is a type of symbol. Symbol in contentful speak is a very short, non-indexed string, and text is their sort of long-form string. And then category comes back with validations on it, which is basically just an enum, right? So we can spit out a GraphQL enum and do queries based on that GraphQL enum now. And it basically looks like this when all is said and done. You have your blog post, you have a title, you have a body, you have a category. You set up a new scalar for symbol because Contentful likes to call it symbol. And then you have your category, which is your enum. Then we can look at the GitHub GraphQL API. And this feels a lot like cheating. I probably wouldn't do this if I was hosting a live GraphQL server in production with, say, like user authentication and things like that. Just because it's when you look at the schema.json file, you basically get this data key and then this __ schema key. And if you've never seen JQ before, it's a command line tool for interacting with JSON. So basically just accessing .data.schema out of the schema.json file, piping it through and getting all of the keys off that object. Now, the one we really care about is actually types. The others are interesting, but not really relevant to this talk. And types is just an array of a very verbose way of writing all of your GraphQL types. So if you've ever looked at this schema.json file, if you've been trying to use Relay or something like that, you've seen this kind of thing before. This file gets very long. There are a lot of things in here that you may not expect to be in here, defined as types, if you have never looked in here. So if you have one, go look at it when you go home. But for example, this markdown type is an object. It has some fields. One of them is attributes, which is that computed bucket of fields that we were talking about before. And then you get the type of that, and so on and so forth. So you can take these, and if Graphical sends an introspection query to your GraphQL server, which at this point is basically running locally, you can make the query at that time, merge the introspection queries, and send it back. And Graphical will think that you have this really nice, wide GraphQL endpoint that you can query. So if you, say, have like a GraphQL key, you can then patch the introspection query from the GraphQL API onto that key and get introspection ability in Graphical. That gives us a different problem. And that now, how do you query that GitHub key that you've created sort of artificially? And if you look at the resolve function for this GraphQL, you see that there are a couple arguments to it. There's the root value, there's the arguments, there's the context, which is sort of a nice thing to stick things on, and then there's info. And info is the thing we really care about here. Info is this. And this is not trivial if you've never looked at the interior of GraphQL types. Basically, the one that we care about is field ASTs, which will give us the ASTs for the fields in our query at this point in the query. You can see that there's another one called path, which will give you your position in the query, among other things like fragments and root values. Luckily, there's a package that people have written so that you don't have to go in and manually merge all this stuff together. Basically, you use GraphQL parse fields or something like it. You apply it to this info type, which has all of the information you actually need to figure out what to do with the AST. And you get, effectively, this parsed subquery. And this parsed subquery is really nice because it looks super familiar. It's basically already GraphQL. And then you can send that to GitHub. You can get the query back, and then you can send it back down to the client. So that is GraphQL APIs for content-based sites. I hope you learned how we might be able to reuse these content types across projects. Exposing the processed data behind them is a different talk in itself. Merging GraphQL schemas, there's a couple issues here if you're interested in that kind of thing. Contentful, there's a link here too. And then the project that I was talking about, Leo, which implements these ideas, is at superawesome.labs/Leo, if you are interested in that. I'm happy to answer any questions either now or file an issue.
Questions?
So the whole merging remote things, like, have you built like proof of concepts with this, or have you built like? You think this is going to be something that's like can work with any third-party GraphQL endpoint, or is it always going to be?
I think that
case by case.
It can work as long as the so basically one of the big issues is how you rename the types that are in that API so that you can access them.
Yeah, so they're on their own namespace.
And basically the standing solution to that is prefix it.
Yeah.
Right.
Yeah.
It's not a pretty solution, but it works.
Yeah.
I don't know if this will become common practice, just because authentication in GraphQL APIs isn't necessarily a solved problem for everybody. And things like that, like subscriptions, like how would you merge that in and then access it, become a little more complicated. But in this basic sort of situation that we're talking about, yeah.
Yeah. Well, I think there'd be like enough open, GraphQL instances that a generic NPM package that, someone like me could use. Would be nice.
Nudge.
Yeah.
Other questions?
Cool.
Well, if nobody has another question, I actually have one. So is this stuff that you actually use in your day-to-day work now, or is it like something that you've just like playing with and came up with on the side?
I came up with it on the side, and now anytime I have to build sort of a static site or a progressive web app that has mostly static content, I use it.
And do you find that like to actually make it faster for you, or is it just like an intellectual exercise?
Yeah, it makes it a lot faster for me because I get to reuse. So Leo actually has a lot of things on the back end of this that make it really nice for building, say, a progressive web app with Preact and reusing my component library that I built over here, and not have to rebuild all of those components and then use them in like Jekyll or something like that. The way it works is basically like you have a universal application and you render out your HTML pages in this universal application, and then you render out JSON files, which you can then query with Apollo. So it's the combination of all of those different things that make it actually very productive. Okay. And then you get to use cool tools like Clamor if you want to.
That does sound pretty cool. All right, we're going to take a very short break now, about 5 minutes, and then the last talk will be by Danielle Mann, who works here at Meteor Development Group and who is one of the authors of the Apollo GraphQL developer tools, and who also happens to be using those developer tools in her everyday work. So she'll be telling you all about that. All right, well, we'll resume in about 5 minutes. Right, we're going to try to resume in about a minute, so if you could find your way back to your seats, that would be great. Okay, so for our last talk of the night, we have Danielle Mann, who will be talking about GraphQL or Apollo developer tools, which she built and which she also uses every day. So please welcome Danielle.
Sweet. Thank you, Jonas. Hi everyone. I'm Danielle, and I'm a front-end web developer here at MDG. So thank you very much for coming and sharing in this meetup at our office today. So our company, we do sort of two categories of engineering. We build a whole bunch of open source tools, a lot of which are around GraphQL, and I'm sure you guys are familiar with our Apollo project. And then we build two services on top of those tools. And our services are both built using GraphQL. So as a front-end web developer on our services team, that means that GraphQL is a huge part of my workflow every day because it's how I get data from our server into our app and the app code that I work on. And then I also work on our GraphQL Performance Insights tool, so there's that effect as well. So the title of my talk is Easier Developing for Happier Developers. And that's not only very vague, but it's kind of cheesy. So I just wanted to explain it. I firmly believe that any developer using GraphQL is a happier developer than someone who is using other things. Like, that's the whole reason GraphQL exists. And I called it Easier Developing for Happier Developers because what I'm going to be telling you about today is a project that the Apollo team did about a month ago called Apollo Client Chrome DevTools. And it's something I'm really excited about because I think that DevTools are an essential tool for every front-end developer's workflow. And you should want and feel like you deserve DevTools for every part of your stack. So I'll be talking about sort of GraphQL DevTools in the context of these Apollo Client DevTools we built. So here I've just got a sneak peek of our DevTools if you have never seen them before. You can see I've got the Chrome Developer Console open. I'm on the Apollo tab, and these are the DevTools. But I'll get into that a lot more later. So what I'm going to talk about is first, why we built these DevTools, why we felt the need. And then I'm going to go over some of the main features of our DevTools. And then I'm going to talk about how the existence of these DevTools over the last month has vastly improved my workflow as a front-end developer. And then I'll finish up with sort of my vision of how I think DevTools could be really impactful and awesome for everyone in the future. Yeah, so let's get into it. So there are lots of reasons why we all love GraphQL. It's strongly typed. It only gives you exactly what you ask for. It simplifies your client logic, etc. But if you're going to start building with GraphQL, there's sort of more that you need aside from just GraphQL, which is like a protocol to get your data. You're going to need to be able to cache data in your app. If you're building progressive web apps, you're going to want to be able to provide optimistic UI. You're going to be able to want to paginate your data. Like one of the main uses for Facebook's GraphQL, I think at the beginning, was like their newsfeed. So you're going to be able to want to do all of these things. And all of this logic is quite complex, but it's not actually related to your own app logic. So that's where GraphQL clients come in. Because it's complex logic, but you don't want to have to build it yourself and then repeat it in every app. So our open source team has a lot of awesome GraphQL clients and projects. We primarily, I think, have Apollo client, Apollo iOS, Apollo Android Cooking, in addition to all these other GraphQL tools that we have. And when we started building with GraphQL and Apollo client on our services team at the beginning, we sort of started to realize that these clients are quite complicated. And so under the hood of the open source team, or of Apollo client that the open source team built is Redux. So Apollo client uses the Redux store to store everything and to be able to cache your data and stuff. But when I first started using Apollo client, I didn't know any of this because the whole point of Apollo client is it abstracts this away for you, so you can use it in the abstracted way that they built it, and you don't have to know this. Yet when I started having to debug deep problems in my app specifically, and I started needing to be able to view the cache of my app, I started having to delve into this and go into the Redux dev tools and view the store of my cache and stuff. And it was kind of complex, especially for someone who didn't build Apollo client to start with. And for me, this was pretty easy to do because I could just walk across the room and go to someone who actually built Apollo client and get them to help me. But I imagine for a lot of people who use Apollo and our other awesome tools who don't have that luxury, debugging can be kind of complex. And so a few months ago, when we first started dogfooding our own open source stuff on our services team, we started realizing that this might not be super easy for all of our users outside of the company. And so we started throwing around this idea of Apollo client dev tools. Sort of over lunch conversation, we would talk about what types of features we want, what types of things we want to be able to see and stuff. And then a month ago, we had a company-wide engineering hack week. So I actually got to pair up with some of our core contributors on the open source team and build these tools. And so this is just a picture of the Redux dev tools. And the whole point is that you can see all this Redux-specific stuff, like the actions and the dispatchers. But when you use Apollo client, you don't care about any of that stuff as a user. You only want to be able to see this stuff on the right, which is the state of your cache. So the whole point of our dev tools was to allow you to sort of develop and get the same debugging experience, but way better, because you could debug at sort of the abstracted layer of what you're used to using Apollo client at. So the next thing I'll do is just talk about the features that I've been hyping up in our dev tools. The three main features are, one, there's a graphical implementation. So we put graphical into the dev tools. And that's huge. And if you guys don't know what graphical is, it's just an IDE to be able to talk to your GraphQL endpoints. Another one is we put a query watcher into the dev tools. So you can now see every query that your app is using in the dev tools, which is also huge because that's something that you just simply could not do before. You didn't actually know. And then three, we made a store inspector. So this does show the same technical data as the Redux store, but it shows it in an Apollo client-friendly way. So GraphQL is a graph, so your cache is actually a graph. Different objects have different references to other objects. And when you're inspecting your cache, you want to be able to follow these references. So that's what our store inspector does. So I have a few demo videos to show you the dev tools. This is the first one with graphical. Sweet. So it's a pretty simple video. Anyone who's used graphical before, that's probably very familiar, though we have changed the CSS a little bit. But I just wanted to go over sort of the features that you just saw of this feature in bulleted form. So first off, putting graphical into the dev tools, it puts an IDE for your GraphQL endpoint straight into the same page that your app is looking at. And so what this means is typically if you're going to set up graphical, graphical is not something we made. It's something Facebook made and exposed as a React component. So you can take it and in a separate route on your app, you can plop it there. Or maybe you can set up a separate URL with this graphical IDE. But when you set up graphical that way, you usually have to end up implementing custom logic, like login buttons or something. And it can be a little bit of a process to set up. But by putting it here into the dev tools, we were able to leverage the fact that Apollo client already has all of that configuration for you. So you don't have to worry about your query headers or your authentication or anything, because it just automatically takes that data from Apollo client, and it's magically there. So there's no configuration necessary to set up an IDE to talk to your server endpoint, which we think is huge. One of my favorite features of GraphQL is the Schema Explorer. So schema auto-documentation, I think, is an awesome feature of having the dev tools in the same page as your app, because if you want to go and see if something is implemented by your backend team, or like see if something about your schema has changed, you just can go explore your schema right there, and you don't have to ask them. You don't have to hope that they've updated their documentation. Like, it just gives you the hard truth. Through this implementation of GraphQL, you can query your endpoint directly, which it always does. But one of the cool things we've added is this load from cache button. And so this allows you to actually query the state of your cache. And so you can sort of see what your client would see and see what data is left to be fetched. And then lastly, one of my favorite parts about putting GraphQL into the dev tools is that it's in the same page as your app itself. And so as a front-end developer, I have this vision of what the ideal front-end developer experience would be. And my vision is you never have to leave your app to develop it, to debug it, to improve it. Like, all you have to do is have your editor with your code, and then your browser with your app and your dev tools, and like that's it. And so putting GraphQL in here is huge, because now you don't have to leave your app to get information about the data your app is getting. Like, it's just all there. OK. The next is the Query Watcher. So here's my next demo video. You can see we're now looking at the queries that this specific page is showing. But as we change pages, this list of queries actually also changes. And if we click on one of these queries, you can see they're kind of shifting in color. That means they're reloading. You can see a really nicely syntax highlighted version of the entire query string and the variables it's using. And it was pretty quick, but if you caught it, there's a Run in GraphQL button. And what that does is it copies your entire query string and the variables, and it takes it to the GraphQL pane, it pastes it there, it clicks the Run in GraphQL button for you, and it fetches the data. So like, that all happens super quick. That's definitely my favorite part of like the whole DevTools, but I'll get into that later. OK, so the bullet-pointed list of features here. One, you see the list of active queries in your app. And as I mentioned in the beginning, this is something that just didn't exist before. Like, you could never see this so simply. One of my favorite parts about being able to see this list is you can really easily visualize the different data densities of your pages. So for example, your login page, it takes very little data, because all it needs is data about your account. But I showed a page up there where there were a ton of graphs, and those graphs are live polling data so that they update and stuff. That page has huge data densities. And so as you click through the different pages, you can see these densities really easily, and I think that's pretty cool. If you're using React and you're using the dev tools, you can see the React component that the queries are wrapped around, which is really valuable, because if you actually want to go into your code and like find where this query is and find the component that's getting its data and consuming the data, now you already know the name, so you can just find that super easily. You can inspect your query strings. This is particularly valuable if you're using fragments that are maybe shared across queries, so they might be stored in different files. And so here in my snippet, which hopefully people can see, we have a query that's using a fragment. And so normally those are in separate files, but here you can see it all in one. And you can view the variables that it used, which is actually a huge feature, because a lot of times variables are dynamic. So they change based on buttons the user has clicked on their app, or based on the URL that the user has. So you don't always know what query variables are running. But here you can see, so you know. And then, as I said before, this Run in GraphQL button is like definitely my favorite part. So before, if I wanted to sort of figure out and recreate some query that my client had done, what I would have to do is figure out where the query lives, copy that, paste it into GraphQL, find all the fragments it was using in different files, copy those, paste them into GraphQL. And then if I wanted to recreate the variables my client was using, since our variables are dynamic, I would usually have to like go and console log something, like read what variables I used, paste them into GraphQL, and then I could do it. So it could easily take like 10 minutes to set all this up just to recreate one state. But this Run in GraphQL button takes like 1 second. It's amazing. It saved me like hours, I think, in just a month. Okay, the last feature is the store inspector. So here's my demo video for that. You can see a list of all of the objects by their ID, and then you can search them. And you can open them as a tree, so this is actually a reference to a different object. And I clicked a little arrow that was right next to it, so it hopped to that other object. That's what you saw there. So the value of having a store like this is that you can inspect your client cache in an Apollo client-friendly way, because we normalize all your queries. And so anytime you make a query for some object, and we already have a version of that object stored in the cache, we take the IDs and we match them and we merge them together. And so the cache is actually kind of flat, but like in our mental model, it's all a graph. So you want to be able to traverse the different links. And so that's like a huge part of why we implemented this ourselves, even though it does already exist in the Redux DevTools. And then definitely the best part of this is being able to search through your store. So the search, it allows you to search by both key and value. And this is huge because in really, really big client apps where your cache is huge, like it would be literally impossible to find like some small string without a search function. So the search is enormous. Okay, so I just wanted to show you like a side-by-side of sort of Redux DevTool search, or Redux DevTool store versus our store. You can kind of see the difference there. Okay, so workflow improvements that I have personally experienced. I've already sort of divulged them all, but in an organized manner, I'll just say that definitely the biggest benefit of having the DevTools is that everything is all in one place. So most things were in one place. Like I could edit my CSS and my JavaScript. I could learn things about my network already through the Chrome DevTools because they're great. But now I can also learn everything I need to about data from my server, like also through the DevTools. Like I cannot emphasize enough how awesome that is. And so I just sort of to emphasize that more, will tell you a story of something I experienced trying to implement a client feature using a REST API on like a different team that wasn't at this company. So the first thing I had to do was spec out what my client needed, like what my feature needed, look through our API, see if they already had what I needed, but they didn't, so I had to spec out my endpoint. And then I had to write documentation for it, and then I had to take it to my backend team and convince them that they should implement it fast, and then wait for them to implement it. And then once I had the implementation and there was some documentation, I had to figure out how to actually query the endpoint because I had to get, like the authentication headers and stuff in. So I finally figured out that stuff. I figured out the variables, and I made an AJAX call. But of course, I came up with an error. And so I opened Postman, and this might seem like a long story, but that is exactly the point. So I opened up Postman, I copied all my headers into Postman, I rewrote my query in Postman, I tested my endpoint until it worked. It turned out that the whole reason it didn't work was from some silly typo, which totally sucked. So I finally got something that worked. I copied it back into AJAX. I got my data. Of course, there was no way to inspect it, so I logged it to the console. I had this JSON blob that I then opened all these tiny carets for it to figure out what it actually showed me. And finally, once I decided that it was correct, I could actually go and do my job, which was to write the front end for this data. But now, thanks to GraphQL's awesome workflow and then the added awesomeness of the new DevTools, this same workflow is much simpler. So all you have to do is open the DevTools and inspect the state of your schema and API using GraphQL's schema auto documentation that I talked about. If something's not there, you do have to go and talk to your backend team, of course. But you'll know when it's there and ready because thanks to this introspection query, you know the hard truth of what your server has available. So once you know it's ready, you just write your query. You're already in your app. You can validate that the data is correct because GraphQL shows you the data. You don't have to log it to the console. And then you write your query, you get it perfect, and then you just go and plop it in your code. So this is huge. No more relying on docs, no more test and guess and check. You know exactly what to do. Okay. So the last part of my talk is sort of my vision for the future of how I think DevTools could be awesome, especially for GraphQL. So these are just sort of a few speculative ideas that hopefully you get excited about because I'm excited about them. So one idea for a DevTool improvement would be the idea of workspaces. So this past November, the Chrome DevTools team, they announced this like experimental thing where you could have workspaces where if you change CSS in the DevTools, like that would actually save to disk and like change files on your disk. So my idea here with GraphQL DevTool workspaces is what if you could change parameters of your query. So like maybe your query has a poll interval or something, and you could change that like right through the DevTools, or you could change like some other thing about your query and like save that right to disk. Another idea is snapshots of the client-side store. So the idea here is since we now know like exactly what the state of your cache is at certain points, what if you wanted to report a bug, all you had to do was like click this export button. It would like export it to a file, and then you just send that along with your bug report, and like there's no more problems of like I can't what's the word? Reproduce, yeah. There's no more problem of like I can't reproduce, because if you see the bug and you just like export the state of your cache, like they'll be able to see the bug too. And then another idea here would be you can compare like how a pull request changes the state of your cache. So like maybe before and after like a particular commit, you could compare what the states of the cache would be and either make sure that they don't change or make sure that they change in exactly the way that you wanted. Another idea here could be errors. So what if you could show GraphQL errors like really, really nicely somehow in the DevTools? Because currently they're kind of cryptic. I don't know if you guys have had this feeling, but like they are kind of hidden sometimes. And then also here, like what if you could print errors from your GraphQL server right to your console? So this would also tie into the idea of like never having to leave your app to like debug something, because it would just come right to your client console. And then a final idea would be maybe some graphs about performance. So what if you could show some sort of version of the network tab on the DevTools, but in a GraphQL-friendly way? Or what if you could show like the fields that all of those queries that were in that list were using specifically, and then like compare that against what your schema is actually offering to make sure that you're offering like things that are aligned. And so here at the bottom, I've put the link to our GitHub repo. It's github.com/apollostack/ApolloClientDevTools. So if you guys have any ideas or feature requests or anything, you should just go to our GitHub repo and like open an issue. We'd love to have a conversation with you. And that's a perfect tie into something we're actually doing really soon called Apollo Contributor Week. So we're always looking for more contributors to our Apollo tools, because we firmly believe that the people who use our Apollo tools are like the best people to contribute to them, because they're the ones whose lives we would make better. The whole Contributor Week was actually inspired by our Hack Week, because I normally don't work on our open source team, but I got to work with like the core people and make this tool that has been amazing for my workflow. So that's the whole idea of Contributor Week, is like opening it up to the whole community. So you should come to Contributor Week or participate and get help and mentorship from our core team to like build things into Apollo that you've always wanted. Okay, so here is just a screenshot of the Chrome Web Store with our DevTools. It's an extension. You can find it in the web store if you just search for Apollo or GraphQL. And if you're using Apollo Client, like you should definitely download these. We've already got 1,100 people like happily using them, and we've got some great feedback. But just to tie into what I said about at the beginning about GraphQL DevTools in general, if you're not using Apollo, I hope that I've made it clear that there are some really great benefits that are coming from GraphQL specifically. So whatever your GraphQL stack might be, I hope I've inspired you to maybe spend a week and make your own GraphQL DevTools, because a week of time now will save you like many, many weeks over in the future. And I'm a much, much happier developer myself, thanks to the DevTools. So easier developing for happier developers. I hope that that title is a little bit more clear now. Thank you all for listening.
All right, questions over here.
Is the extension plugged on the Apollo Client store or on the network tab?
It was a while back in my slides. So the extension is actually its own tab in the.
No, but like, does it look at the network to like figure out the queries?
No, it looks at the Apollo client.
Okay. So I
object.
cannot use it with Relay.
With Relay, no. Unfortunately, this is Apollo client specific. But a little bit under the hood of the implementation is what we've done is we've exposed the Apollo client object onto the window object. So yeah, all the data it's showing is like stuff specifically from Apollo client.
Makes sense.
Maybe it's time for someone to build Relay dev tools.
Yeah.
Does this work at all with SSR, so you can see the queries that the server kind of, I guess, executes?
I don't actually know. I would love to talk to you after. I might not be the person for that question. Yeah, sorry about that.
Is there a way to set headers in the graphical dev tool so that we can do things like set an authorization header?
So what this implementation of GraphQL does is it just makes queries through Apollo client itself. So if you've set up Apollo client in your app and you've got queries working through Apollo client, like it's making queries through like the same interface your app is making. So if you want to set specific like authorization headers, you would probably do that in your Apollo client config, but it should already be there.
All right. If there are no more questions, let's thank Danielle again for an amazing talk. So that's pretty much it for tonight. We'll be uploading videos of all the talks onto our YouTube channel. So if you've missed something or if you just absolutely want to watch it again, you can go find that on YouTube. And if not, I hope to see you again in 2 months at our next GraphQL meetup here. And also, don't forget to download the developer tools. And maybe if you're interested in it, take a look at our contributor week, which is going to take place in about 2 weeks. So stay tuned for that. All right, thank you all for coming, and have a good night.